Across medieval Europe, shipbuilders faced a problem that every naval power feared more than storms, pirates, or even rival kingdoms: moisture. Saltwater didn't just wear away the hull. It invaded the wood from the inside, swelling planks, rotting beams, and, well, turning warships into sinking liabilities. Fleets that should have dominated seas were instead crippled by slow internal decay. Yet certain maritime cultures, particularly Norse, Baltic and early Mediterranean shipwrights, managed to keep their vessels seaworthy for decades. Their ships crossed entire oceans, endured constant soaking, returned battered but intact, and really they proved that they had access to a moisture barrier so effective that it gave them a military and economic advantage. This barrier wasn't modern paint or chemical sealant. It was a method crafted through observation, controlled heat, and natural waterproofing compounds. Today, on Thermal Vault, we're uncovering the medieval moisture barrier that saved entire fleets, exploring how it worked and how its principles can still be applied today. The barrier's success begins with a deep understanding of how wood responds to moisture. Medieval shipbuilders treated wood not as a fixed material, but as a breathing, expanding, contracting structure that required preparation before being exposed to seawater. They understood that raw timber absorbs moisture unevenly, causing distortion that weakens the hull long before rot becomes visible. To counter this, they developed a multi-stage preparation ritual that changed the internal structure of the planks themselves. The process started by selecting dense, slow-grown timber and drying it gradually under shade to prevent rapid expansion when first launched. Drying wood slowly ensures that its internal fibres settle into alignment rather than cracking under stress. Anyone working with outdoor lumber today can use the same method simply by seasoning wood under partial cover, rather than leaving it fully exposed to sun or wind. The critical step in the medieval moisture barrier revolves around ecological oils and heat. This was the heart of the method, and the reason it remains one of the most effective natural waterproofing systems ever developed. Shipwrights boiled a mixture of linseed oil and pine resin until the two bonded into a thick, penetrating liquid. When applied to warm wood, this mixture seeped deeply into the grain. But they didn't stop with a single coating. They heated the planks with embers or warmed stones placed along the interior of a half-finished hull. As the wood heated, pores expanded, pulling the oil-resin mixture inward. Once the heat subsided, the pores closed again, locking the waterproofing compound within. This technique didn't just coat the surface. It actually filled the microscopic channels inside the plank that would normally draw in moisture. As the oil cured, it formed a semi-flexible polymer that acted as an internal waterlock. The result, well, was timber that no longer behaved like a sponge. Modern woodworkers can replicate this by heating linseed oil before application, treating both sides of a plank, and then using a heat gun or, a carefully managed fire to encourage deeper penetration. The key principle here is warming the wood slightly, not scorching it, so that the oil sinks in rather than just sitting on the surface. The barrier relied on multiple protective layers, and each served a rather precise function. After the deep oil infusion, medieval builders applied a resin-rich protective coat. This was made by boiling pine resin with charcoal, and sometimes a small amount of animal fat, to create a pliable sealant that resisted cracking. When spread across the exterior hull, it repelled waves, delayed salt penetration, and added a second line of defence over the oil-saturated wood beneath. Only after this resin layer cured did they finish with pine tar. Tar was, you could say, the medieval ship's armour. Its molecular structure prevented water migration, and its resistance to salt made it ideal for those harsh sea conditions. Applied hot, tar fused with the resin layer and created a seamless exterior membrane. This triple system, oil inside, resin across the grain, tar sealing the exterior, meant that even if the outer coat wore down, the underlying wood remained protected. Anyone attempting traditional boat restoration, wooden tool preservation, or off-grid construction can replicate a simplified version. Start with warm oil, follow with a resin beeswax mixture, and finish with a thin coat of wood tar. The final result, withstands rain, soil moisture, and long-term exposure better than untreated timber. The durability of medieval fleets came from maintenance as much as initial treatment. What saved entire fleets wasn't a one-time coating, but a maintenance cycle rooted in discipline. Medieval crews periodically hauled vessels ashore, scraped off marine growth, reheated the hull under the sun or by smouldering fires, and reapplied tar. The result was wood that remained stable and protected for years, even decades. This ritual maintenance extended the life of ships well beyond what many modern wooden vessels achieve without chemical treatments. For practical use today, even something as simple as an annual re-oiling of garden tools, shelter supports or wooden frames keeps them from rotting, A survivalist maintaining an off-grid cabin can apply a traditional oil and tar treatment to exposed beams before the rainy seasons arrive. Reapplying a thin coat every year or two, it dramatically extends the lifespan of any outdoor wooden structure. The medieval moisture barrier really proves that ancient engineering solved environmental challenges through method, not mystery. What makes this technique so remarkable is not that it was primitive, but that it was methodical, honestly. Every step, from wood selection to the sequencing of heat, oil, resin, and tar, was developed through long-term observation. The resulting barrier was so reliable that entire naval campaigns depended on it. The rediscovery of these systems is not just an academic curiosity after all. It offers real solutions for preserving wood in environments where modern chemicals may be unavailable, impractical, or simply undesirable. It provides builders, historians, and survivalists with a set of proven techniques that treat wood from the inside out rather than relying solely on surface coatings. For more historical preservation methods, forgotten engineering strategies, and deep-dive breakdowns into ancient technologies, do subscribe to Thermal Vault and share this video. The more support the channel receives, the more lost knowledge we can bring back to life.